Alright, now we're starting at problem 7. This is the ambiguous case of the law of sines. So, gotten started, but let's finish it. Triangle WXY has the problem properties. The angle at vertex W is 14, the angle at vertex X is obtuse, that means greater than 90. The side opposite vertex W has a length of 7 units, and the side opposite of vertex X has a length of 9 units. So we have W equals 7, X equals 9, angle W equals 14. So first we need to solve for angle X using the law of sines, because that's the only one we can evaluate for the moment. So the law of sines, sine of A over A equals sine of B over B, etc. equals law sine of C over C. So the sine of 14 over 7 is equal to the sine of X over 9. So 9 times the sine of 14 over 7 is equal to sine of X. All I did from step 1 to step 2 is multiply each side by 9. So the 9 cancels out on the right-hand side, and you have a 9 as a coefficient in the numerator for the right-hand side, for the left-hand side. Now, in order to get X, I need to remove the sign. In order to remove the sign, I take the inverse sign of each side. So from steps 2 to 3, I took the inverse side of each side and just flipped it up. So the inverse sine of the sine of X is X. And the inverse sine of 9 sine of 14 over 7 is something I evaluate in my calculator. So I take the inverse sine, make sure I'm still in degrees mode. I am. Take the inverse sine of 9, the inverse sine alpha y, make it a fraction, of 9 times the sine of 14 degrees over 7. So it says angle X should be using the law of sines, 18.12, right? Question mark? Wrong. Angle X is obtuse. Angle X is 90 degrees, or greater than 90 degrees. So what's the deal? What's the case? Well, let's look back to our definition of the sine value. The sine value is going to be the measure of that right angle embedded in the unit circle, theoretically at least. And the sine value can have two possible values, especially when it's positive. When the sine value is positive, our y-coordinate could be right here, but it could also be the same. You could get the same y-coordinate at this angle. Notice this angle is less than 90 degrees in quadrant 1, and this angle is greater than 90 degrees in quadrant 2. So in order to find the true value of X, so that's not 18.12, the true value of X, in order to make the angle X obtuse, we say X is equal to a value that's 180 minus 18.12, because really, if this, let's draw a larger unit circle. If we get this value of theta, the value where we get the equivalent sine value, that value of theta is going to be right there. And so that means that value that we're evaluating is going to be 180 minus theta, because theta starts right here. So X is equal to 180 minus our previous answer. So that's going to be 161.877. So X is equal to 161.877. So now we need to find the measure of angle Y. So angle Y is equal to 180 minus 14 minus 161.877. So 180 minus 14 minus 161.877 is approximately equal to angle Y is equal to 4.123 degrees. So angle Y is 4.123 degrees. Lastly, we can use the law of sines to evaluate the measure of the side opposite y, which is this side. Let's call this side y. Well, we can say that the sine of 4.123 over y can be equal to the sine of, let's just pick w, and the sine of 14 over 7 is equal to the sine of 14 over 7. And so you can cross multiply. Sorry, I should have had a little bit more space, but I'm going to do my next step up here and say 7 times the sine of 4.123 is going to be equal to y times the sine of 14. So you just divide each side by the sine of 14. Sine of 14 cancels out, and that gets you y. So let's evaluate for our final answer. Y is going to be equal to 7 times the sine of 4.123. Let's hope this actually works out. Over the sine of 14, and that gets us an example answer of 2.08. That is our answer, B, 2.08, verified by the answer key at the back of this test packet. So very good. This is the example of the ambiguous case of the law of sines. If you can understand this problem, you intuitively know the sine value on the unit circle. Number 8. Consider these two trigonometric functions. F of x is equal to 3 times the sine of 2x plus 4. G of x is equal to 3 times the sine of 2x minus pi over 2 plus 4. That's going to be equal to 3 times the sine of 2 times x minus pi over 4 plus 4. Now, very important here, you always, for function transformations, even for trig functions, factor out the coefficient of x. So if you factor out a 2 out of pi over 2, that's like dividing pi over 2 by 2, which is going to be pi over 4. So instead of having minus pi over 2, you can have right pi over 4. So, and that, notice, that's the main difference. The main difference between f of x and g of x, you always have a plus 4, but now you have that minus pi over 4. So that's going to be to the right pi over 4 units. The only option there is answer choice B. All right? So you could graph it and then like physically see that that's right pi over 4 units if you did zoom trig. But really, you just got to be able to factor your functions and know what the transformations do. This is kind of like you factor it and you have to recognize the difference between this function and that function. I mean, really, if you want to make it easier, you can rewrite the other function as 3 times the sine of 2 times x minus 0 plus 4, so you can even further see how it matches up. But that's number 8. So for number 9, the maximum height in inches a ball reaches after the first 4 bounces is shown. So we have our x input value, 1, 2, 3, 4, and our height, 4.42.0, 31.5, 23.6, 17.7. So what best models the data? Exponential function. So notice as x values goes up, y values go down. So this is an exponential function. Is this exponential growth? Well, it looks like it's exponential decay, so it probably looks like that. Decreasing by 25%, 75%, or is it a logistic function? Well, logistic function looks like this, if we remember logistic functions. So hopefully if you know what a logistic function looks like, the logistic function does not increase, or does not decrease over time, like potential exponential decay. So we can cancel out C and D. Then, if you have an intuitive understanding of percentages, we can say that the percentage change between one and the other is going to be 31.5 over 42. That's going to be the previous one, so the most recent one over the previous one. And so we can say from one term to the other term, you have a 75% decrease. Or it's 70. The second term is 75% of the first term. The third term is 75% of the second term. So if you're 75% of something, that's going to be a 25% decrease, because 100% is to stay the same. So intuitively, that's a 75% decrease, and that makes it an exponential function. Now, the kosher way to do this is to go to stat, edit our tables, do 1, enter 2, enter 3, enter 4, enter 42, enter 31.5, enter 23.6, enter 17.7, stat, edit, calc. We can do an exponential regression. So we have the exponential function, if we wanted to find the function using a calculator, as 56 times 0.75 to the x. So that's going to be a 25% decrease with each bounce. We can also do zoom stat. Oh, whoops. So I need to get rid of that function and then go to mode. Right. Yeah, so anyway, the answer is A. Hopefully you can just intuitively get it. Okay. Let's go to the inverse function of g of x is equal to x cubed minus 2. It's number 10. So start out y is equal to x cubed minus 2, switch the x into the y's. X is equal to y cubed minus 2, add 2 to each side. X plus 2 is equal to y cubed. Take the cube root of each side. X plus cube root of x plus 2 equals y. So we've isolated y. So the answer is the cube root of x plus 2. That needs to be a gotcha one. That's one you should be able to get with 100% probability. 11. What are the polar coordinates of the point -2 root 3, 2 root 3, where 0 is less than theta, is less than 360? So let's choose B, and B is going to be the right answer. Let's actually evaluate it though. R is equal to x squared plus y squared, and theta is equal to the inverse tangent of y over x. And if you notice something, all R values are 2 root 6 and negative 2 root 6. So the only real point of contention here is theta. And so to find theta, we just need to find the inverse tangent of y over x. Now notice, when you're evaluating things in polar mode, that you're in radian mode. So we're going to go to mode, switch from degree to radian mode, and then take the inverse tangent. Well, normally you're evaluating radians, but I'll actually So normally the angle for polar coordinates are in radians, but if we read the question, that's actually degrees. So we're going to switch back into degree mode. So let's read the question, Mr. Law. Take the inverse tangent of the y-coordinate, 2 times the square root of 3, over the x-coordinate, negative 2 times the square root of 3. And that's going to be negative 0.875 mode. Oh, that's still, for some reason, I thought it was in degree mode, but that's actually in radian mode. So switch, evaluate in radian mode. That's going to be negative 45 degrees. Okay, so now that we have a negative angle, we have to evaluate the negative angle in terms of an angle at a 360. So a negative angle, which is negative 45, we can evaluate it as that's 360 degrees minus 45 degrees, which is going to be equal to 315 degrees. The only option that has 315 degrees is our answer choice in option B. So option B is our answer. This one's a little bit tricky. Want to make sure that you're in degree mode. Want to make sure that you can find theta, our angle of a polar coordinate, from a rectangular coordinate. But we also have to use multiple choice strategies in order to understand negative angles and to pick the best option. Now, let's look at number 12. Which equation is a rectangular form of the polar equation r equals 2 times 1 plus the cosine of theta? I first tried squaring both sides immediately, but I saw that didn't eliminate cosine of theta. So this is a good exercise, seeing how sometimes you have to play around with polar to rectangular. So notice I first squared both sides, say, hey, r squared is equal to x squared plus y squared. I can do something with that. But then we have 4 plus 1 plus the cosine of theta squared, and realized there wasn't really an easy way to eliminate my cosine theta squared. But then I said, what if I multiplied each side by 1 plus the cosine of theta? Well, on the right-hand side, that would cancel out, that would cancel out. On the left-hand side, r times 1 plus the cosine of theta became r plus r cosine of theta. And so I had r plus r cosine of theta is equal to 2. That's what happens when they multiply each side by 1 plus 1 cosine of theta. So that's my first step here. Then I said I wrote for next type, I subtracted r cosine of theta from each side. R is equal to 2 minus r cosine of theta. And then one of the polar equations I just have to know is r cosine of theta is equal to x. So I just wrote r is equal to 2 minus x because I found r cosine of theta, because I eliminate the cosine of theta, turn it into an x term. Now I squared both sides, because I know r squared is equal to x squared plus y squared, so I wanted to get that r squared term. R squared is equal to 2 minus x squared. So r squared is equal to x squared plus y squared, so I had x squared plus y squared is equal to 2 minus x squared, except for now I know that a minus b squared is a squared minus 2ab plus b squared. So x squared plus y squared is equal to 4 minus 4x plus x squared. Subtract x squared from each side, and you have y squared is equal to 4 minus 4x. Now you have y squared plus 4x is equal to 4, and that is an option that we have. Y squared is equal to 4x plus 4x equals 4. Y squared equals 4x equals 4. That's option C. I just got that by manipulating the polar form. So this is a little bit tricky, but you just have to know how to manage polar equations. Number 13. X is equal to 1/3 square root of t plus 3. So the first step for evaluating a parametric equation, and this says when t is greater than 0, and so that's why the function is like thus so. So I have y is equal to 4 times 3x minus 9 squared squared. Let's see how we got there. X minus 3 is equal to 1/3 times the square root of t. 3x minus 9 is equal to the square root of t. 3x minus 9 squared is equal to t. Alright, so that's how I isolated t. Now, one thing that I wanted to do is, for the first step, I did 4 times 3x minus 9 squared minus 7, because I plugged t into y equals 4t squared minus 7. I skipped the next step because I realized that expansion just made things more challenging. So I had 4 times the quantity of 3 times x minus 3 squared squared. So squaring 3, I had 9 times x minus 3 squared squared minus 7. Now I squared both sides again. So 9 squared is 81, and x minus 3 squared is x minus 3 to the 4th power. So I had 4 times the quantity of 81 times x minus 3 to the 4th power. Lastly, I had y is equal to 4 times 81 is 324 times x minus 3 to the 4th power minus 7. That was d. So that shows you the algebraic steps of this manipulation. Eliminating the parameter and using algebra to get to our final answer. Now, another thing I did is in my calculator, I turned into parametric mode. Graphed 1/3 times the square root of t plus 3 and 4t squared plus minus 7, and I just graphed it. And I want to zoom out so I can see what's going on. All right, let's zoom back in. So it looks like it's just coming up like this. But you will notice that if you graph the other functions, it's going to be kind of the same deal with the other answer choices. You'll find that answer choice D best matches the parametric graph. So you can try to eyeball it with your calculator, but the corresponding rectangular graph to this parametric graph is seen right here. But the safest bet is just get good enough at algebra where you can do what I did here. All right, I'm stopping now. For next time, we're going to pick up with problem 14.